Welcome to the technical walkthrough of a project, the Intelligent Two-Wheeler Security Device with GPS tracking and remote control. I am Darshan and I am representing our team from Welltech Multitech, Dr. Rangarajan, Dr. Shakuntala Engineering College. This entire development process was conducted under the guidance of a project mentor, Assistant Professor S. John Paul. His expertise in embedded system and IoT protocols was the cornerstone of a success in integrating these various hardware modules into a single cohesive security net. Before I demonstrate the live hardware, I want to acknowledge the specialized roles of my teammates. Hariharan, our team leader, managed to complex task of system integration and technical documentation. Karthikeyan, our lead hardware engineer, designed the core circuitry and handled the physical assembly of prototype. Vaitishwaran worked as the hardware assistant, focusing on power optimization and ensuring that the electrical connections remained stable under high vibrations environments. My primary responsibility was the full stack development, where I built the web application and established the real time communication bridge between the hardware and the end user. Traditionally, bike security relies on physical locks, which are essentially bypassed by the modern theft techniques. Furthermore, when an accident occurs in a remote area, the delay in medical assistance is often fatal. Our project solves both problems. We have created a system that provides remote immobilization and automated emergency response. A standout feature of our architecture is the smart authorization logic. Even if a thief possesses the physical key to the bike, the ignition circuit remains locked. At the relay level, the bike only becomes operational after the owner sends an authorized signal through a secure web application. This creates a two-factor authentication process for a physical vehicle. We didn't just this as a gadget, we built it as a contribution to global safety standards aligning strictly under with the United Nations Sustainable Goals. SDG 9 Industry Innovation and Infrastructure. We are pushing the boundaries of transport infrastructure by integrating IoT and real time data analytics. By digitalizing vehicle security, we are paving the way for smarter, more connected cities where vehicle can be used to optimize traffic and safety protocols. SDG 11 Sustainable Cities and Communities. Our project directly addresses urban safety by reducing vehicle theft and providing an automated system that sends live GPS coordinates during an accident. We are creating a more resilient urban environment where help is always just a notification away. Technical component breakdown. To achieve this level of security, we used a multi-layered hardware stack. First, Arduino microcontroller. This serves as the primary processor. It handles the low-level logic such as reading the vibration sensors and triggering the relay to cut the engine. ESP32 with webcam module. This is our communication gateway. The ESP32 provides a Wi-Fi and Bluetooth stacks required to talk to the web app, while the webcam captures visual evidence the moment a security breach is detected. GPS and GSM modules. These are the pillars of our remote tracking. The GPS module constantly fetches precise latitude and longitude, while the GSM module acts as a fallback to send SMS alerts if Wi-Fi is unavailable. Vibration sensor. This is the sense of the project. It is calibrated to distinguish between the normal engine vibrations and high impact forces that indicate an accident or a theft attempt. Relay module and DC motor. In this demo, the DC motor represents the bike's engine. The relay module acts as a digital kill switch, physically breaking the ignition circuit based on the logic processed by the Arduino. Power controller. Because bike batteries can be unpredictable, we used a specialized power controller to regulate the voltage and protect our sensitive microchips from the surges. This project isn't just a prototype, it is validated by a piece of intellectual property. And next, we are incredibly proud to share the project patent has been successfully published. This legal recognition from the uniqueness of our integrated logic and hardware design. Furthermore, we have taken this project to several competitive platforms. We participated in the Project Expo at Powai College of Engineering and showcased it at our own Veltec Multitech Engineering College Expo, where it received high marks for its practical application in the real world. Now, I will proceed to the live demonstration. I will show you how the web application with the ESP32 to toggle the relay effectively, enabling or disabling the DC motor. It will also simulate an accident by the triggering the vibration sensor, and my friend will show you how the system immediately fetches the GPS location and pushes an alert system to the registered mobile number.
Let's start our project demo. This is our project. This is power supply unit. The input range from 6 watt to 12 watt, but the output is 3.3, 5 and 12 watt. This is Arduino. We use Arduino as our microcontroller. This is connected with GPS, GSM, vibration sensor and toggle switch. The main purpose of the Arduino is collect the data from the sensor and process according to our condition and give the output. This is GPS, which help to track the current location and send the location to the Arduino. The Arduino process the location and send the current location to the register mobile number with the help of GSM. The GSM play a crucial role to send the location with the alert message to the registered mobile number. This toggle switch is used for emergency purpose, and this is emergency switch. If you turn on this switch, the Arduino process the data and send the location to the registered mobile number with help of the GSM. The vibration sensor is used for accident detection. In case of any accident occur, the vibration is detected and process the data and send a live location to the registered mobile number with the alert message if accident is detected. This is the motor driver module, which help for run the motor. And this is the main thing, ESP32 webcam. We use this for turn on and off our motor with help to the mobile phone. Now we start our project demo now. This is our project web interface. When we turn on motor, the motor is start running, and the ESP32 webcam is used for monitoring the live asset, which is used to track monitor what happened near our vehicle. If we turn off, the motor is turn off. If vibration is detected, the Arduino get the data from the vibration sensor and process it and send a emergency message to the registered mobile number with help of the GSM. And we receive the location to our mobile, and we use a toggle switch for the emergency purpose. If we turn on, this is also receive the information from the toggle switch and Arduino process it and send a live location to the registered mobile number with the help of the GSM. Now we receive the location also.